Did you know not everything in your food makes it onto the ingredients list? While what's listed on the packaging will tell you what makes your food taste so good, there's fine print so fine that you can't even see it. And well, that's because it's just not on there. Sometimes substances can accidentally enter our food that are not meant to be there, and these are known as contaminants. One of these contaminants that you may not have heard of is called chlorate. How did this get into our food, you might ask? Well, it turns out that a chemical we use to ensure food remains bacteriologically safe during processing, called hypochlorite, can actually break down to form a new chemical, chlorate, if not used correctly. Chlorate has been linked to the impairment of the thyroid gland, which is essential for normal growth and brain development. Thyroid hormones play a fundamental role in many bodily processes like regulating our metabolism, and for infants in particular, thyroid gland impairment can lead to irreversible cognitive damage, as well as lifelong stunted development. Chlorate can also change how our blood cells work, meaning that oxygen can no longer be carried around the body to the cells, tissues, and organs that need it. Strict guidelines for how much chlorate can safely be in food and water have been established. For example, here is a typical baby bottle, with blue sand representing water and yellow sand representing infant milk formula made up of skim, casein, whey, and many other ingredients. Even if there was only 1 grain of sand in here representing chlorate, it would be 6,500 times the regulatory limit of 10 parts per billion established to ensure consumer safety, and would never have made it to the supermarket shelf. Therefore, these limits are a major concern for food producers and processors, and here's where my research comes in. I study chlorate in the dairy supply chain, how it can enter food and what happens to it once it's in there. I also try and develop new techniques that can be used in industry to help mitigate chlorate's entry, as well as remove chlorate once present in milk, thus ensuring we achieve the highest standard of food safety across the entire dairy supply chain. My research hopes to not only solve the chlorate issue, but develop a knowledge and understanding that can be applied to future chemical contaminants that may occur, so that the ingredients list can truly reflect what is in the food we eat.